Hi AFM students, this is Miss Van Vickel and I'm going to work some word problems for you so that you can do your homework. I do want to say up front that the process for working the word problems is that you need to identify what kind of sequence you're working with, whether it's arithmetic or geometric. And once you do that, then it's important to identify whether you're trying to find the nth term or whether you're trying to find a sum. And if you're trying to find a sum, sometimes they want you to find an infinite sum, and other times they want you to find the nth sum. So you've got a lot of decisions to make when you're working these sequences and series word problems. Let's do a few together, and I think you'll find they get pretty easy pretty quickly. So the first one is the winner of a contest received $200 at the end of the first year. With a 25% increase over the preceding year, and each subsequent year she received 25% more. How much did the contest winner receive during the first 10 years of payments? Sorry, I have to move the page back and forth. So what I notice is this is geometric. So I know I want to choose one of my formulas for a geometric sequence or series. And I also notice that they're asking me to add up how much she received during the first 10 years of payment. So this is going to be the sum of a finite geometric series. Okay, so that tells me that I want to use this formula, S sub n equals my initial amount times 1 minus r to the n power divided by 1 minus r. And so I know that I'm finding the sum of the first 10 years, that the initial amount was $200, and my rate, I believe, was 25%. So that's 1 minus 1.25 to the 10th power. So the reason it's 1.25 is I'm adding or increasing by 25% over the previous year. And then I divide that by 1 minus 1.25. So if I sort that out on my calculator, what I end up getting is $6,650.58. And that's the answer to problem number 1 in your notes. So let's do the next one. Number 2 says Mr. Turtle is moving along a straight line and he has traveled 8 meters in 1 minute. In the next minute, he travels 4 meters, and in each succeeding minute, he travels 1/2 as far as he did the previous minute. If Mr. Turtle goes on traveling this way forever, how far will he go? So again, I can identify this as geometric because he's traveling 1/2 times the amount he did before. Sometimes it helps to write out the terms. So, for example, I would say, well, Mr. Turtle travels 8 meters, and then 4 meters, and then 2, and then 1. Each time he's traveling 1/2 as far as he did before. So sometimes writing out those terms helps me see whether I've got a geometric or an arithmetic sequence. And in this case, they're wanting me to find an infinite sum. If he travels this way forever, how far will he go? And I know that I can have an infinite sum, that this series is convergent because r is in between 0 and 1. So the sum of an infinite geometric series is given by this formula. And I know that the sum, and this really shouldn't have an n because n is infinity, but the sum is 8 divided by 1 minus 1/2. So 8 divided by 1/2, or 8 over 1 times 2 over 1. And Mr. Turtle would travel a distance of 16 meters total if he traveled in that manner forever. And those of you that were there when I introduced infinite geometric series might notice that this is the same problem that I did when I was talking about getting closer and closer and closer to the wall. So I'm going to stop this video. I think it's long enough. And I think you should try some of your homework problems. And when you hit a snag, come back and watch video number 2.